Okay. So a man 6 feet tall walks at a rate. So let's say that, yeah, this is weird, but let's, oh man. So let's pretend like he's walking this way, guys. I'm not going to try to fix that, but he's walking this way. So turn his body and walk that other way. All right. He's moonwalking. There we go. Moonwalks. There you go. I love that. Who said that? Bonus points. All right, here we go. A man 6 feet tall, so 6 feet, moonwalks, that's awesome, at a rate of 5 feet per second toward a light pole. And the light pole is 16 feet tall. That means his velocity, well, we'll get to that. Hold on, just a minute, hold on. So at what rate is the tip of the shadow moving when he is 10 feet from the base of the light? At what rate is the length of the shadow moving when he is at 10 feet from the base of the height? So listen, this is a little bit difficult to see. So here's his shadow. Because it's a light, right here, here's the light, it's emitting, it creates this shadow on the ground. Now, the tip is just referring to, at the tip of his shadow, how fast is that moving? Whereas the length is talking about the entire length. How fast is that moving? You with me? So think of the tip of the shadow like one point that is moving. But think of the length of the shadow as a line that is getting smaller. Can you tell me why this line is getting smaller? Because I'm going to the light, and the light is going to emit a smaller shadow. And see, you have to develop this from a problem, from all this experience, because there's a lot of different types of problems you can create. Yes?
Are we measuring like the rate at which the shadow gets smaller?
Well, let's do that together. Well, I'm not there yet. I was just trying to understand, make sure that you understood a point versus the line interpretation. I'm trying to help you this right now. We're still doing that. Okay. Now let's go to the rates. Okay. But are we understanding, guys? Do we understand the picture? All right. Here we go. The rates. What rate is given? 5 feet. Should it be positive or negative? Negative. Now here's the difficult part. What do we label it? dx over dt? Alright, here we go. No worries. I don't expect you to, because this is a difficult problem. And when I first looked at this years ago, this is actually a similar right triangle kind of problem with proportions. And it's hard to see that. But what it really is doing, and I want you to write this in your notes, it's this picture right here. And what I want you to do is I want you to label this X. I want you to label this, I know it's counterintuitive, Y. I want you to do this as height and this as Z. Okay? So the distance that he is away from the base is X. Go with me? Okay, here we go. We need to set up, so if we're asking for part A, at what rate is the tip of the shadow moving? First of all, we can finally put this, what this is equal to. There you go. dx over dt. You understand? If you don't, you have to stop me right whenever it happens.
Is it because he's already passed y?
So y is the measure of that length. You're never past y. There's always a y in between your feet and the tip of the shadow. And there's always an x per se, unless you're right on the flagpole, between you and the light pole. Okay? Alright, so part A says at what rate is the tip of the shadow? The tip of the shadow will be d something dt when what? Come on, guys. X equals 10 feet. This is for the tip of the shadow. The length of the shadow is something else. It's d something dt when x is 10. Here's what we do. Which one of these, be honest, some of you are really thinking about this to far level already. Which one is easier to name right now? As far as d something dt, the tip of the shadow or the length of the shadow? The length. What is it? dy dt. Don't overcomplicate the tip of the shadow. What is this? And then the biggest reason is this. Nice. X plus y. X plus y is that one. Now let me tell you why. It's in reference to the light. I need to talk about from the light pole to get the tip of the shadow, I need the x and the y. Because if I'm just talking about the length, I know the light's related to it, but I'm talking about from my feet to the tip of that shadow. That's the length. You with me? So I don't need x plus y for the length. It's just from my feet to the tip of the shadow. We good? Alright. So this one, I'd say is a level 7 or 8. Okay? Just because when and where you use this can be a little bit confusing. And the diagram alone was hard to come up with. Alright. E. The equation. From all the pieces that were given, remember, I didn't draw them over here, but I'll do it now. 16 and 6. From all the pieces that were given, what do you think is a good equation that we could create from this? Don't be afraid, try it. Kevin, what would it be? No idea. Grant.
Square root of z squared minus h squared equals x plus y.
Okay, so he's going straight for Pythagorean theorem. Do you hear what he's saying? He's going. What? It's not. Hey, that's a good attempt, though. I mean, that should be your first go-to. When you see a right triangle, go straight to Pythagorean theorem. Okay, but it's not on this one. Okay, this is why it's a level 7, because a lot of people don't think of it. It's a proportion. So 6 over y, or you could put y over 6. The height to the base is proportional to the height, you with me? To the base. Now, can someone tell me, why did I put 16 instead of h? Because it's constant. That, plug it in now. Because that I keep saying flagpole, that light post will not change. Okay? Why is it 6? Because hopefully that person's height doesn't change as they moonwalk. Okay? That'd be cool. Alright. Yeah. Alright, so from here we go. You're going to get 6x plus y is equal to 16y, which you could simplify to 6x plus 6y is equal to 16y. All I'm doing is basic algebra right now, which you can simplify to 6x is equal to 10y. Guys, believe it or not, your equation is that right there. Okay? Which is weird. But this is the proportion that x is related with y. So here we go. Does x change? Does x change? What we said was x. Does it change as he moonwalks? Yes. So leave it as x. They both change. So we're going to leave them as their variables right now. Okay? Here we go. Should I change x to y? No, because how else are you going to use this piece? Okay, here we go. The derivative of the left is 6 dx dt. The derivative of the right is 10 dy dt because of constant multiple rule. You with me? Dx dt is negative 5. So therefore, dy dt is what? Negative 3. So here we go. Dy dt, which is the length of the shadow, part B, is a negative 3 what? Feet per second. Is it seconds squared? No, because it's not acceleration. Is it feet squared? Whoops. No, because it's not area. So how do we get this? You just add them together. Guys, this right here is dx dt plus dy dt. So we're going to plug, we just found dy dt, and if we plug it in here, negative 3, and we're going to add it with dx dt, we get negative 8. D of x plus y over dt. Otherwise, the rate of change of the tip of the shadow is moving negative 8 feet per second. Listen carefully. On the test, you also have free response questions to where I want you to describe it in words. So if I said, at what rate, in a sentence form, at what rate is the shadow moving? This is very important. Moving and changing are different. Changing is like velocity. Moving, who said that? Is like speed. Because speed is the absolute value of velocity. So in other words, the speed limit on the highway says this. So I've thought about that too. Well, what if I don't go 80 and I went negative 100? Could they give me a ticket? Well, yeah, they could because they're saying the speed limit. They're not saying the velocity limit. But anyway. That'd be cool. All right, velocity is changing, speed is moving. So with this one right here, whoops, you're going to say that the rate of change of the shadow for part B is moving at a rate of 3 feet per second. Okay? This one is moving at a rate of 8 feet per second. But it's changing at a rate of what? Negative 8. You with me? It's changing, let me finish this up, at a rate of negative 3. What if I had, let's say, a radius that was decreasing at negative 3 inches per second? I would say this. It is decreasing at 3 feet per second. Because if I said it's decreasing at negative 3, I'm actually doing a double negative, and I'm saying that it's increasing. So now you know, moving versus changing versus decreasing or increasing. Know how to use them when and where in sentence form. Okay? If you have a question on that, I can answer it right now.
I was gonna ask, like, when the person is moving towards the light pole, would you say is moving at, like, whatever it was towards the light pole, would that be wrong, or is that
Okay, so let's say that this person is here, and you're moving toward this. What is it that you're talking about? Are you talking about the rate of this? Okay, so you're going to say, let's say that this rate is negative 5 feet per second. See, this is easy when I ask you to do it in this form. But when I tell you to do it in sentence, then that's when the questions come in. You could say that it's moving at what? 5 feet per second toward the pole. You could say that it's changing what? At a negative 5 feet per second toward the pole. Because the changing is constituting that magnitude. Is it a positive or a negative direction that this thing is changing? Go with me? And the decreasing, you would say it's decreasing. You could say, I see what level you guys are asking now. So, if you're decreasing, you would say that the rate of change, since it's already negative, is decreasing at a positive. Okay? You won't have questions to that level. You won't. Nowhere near that level. That's cool stuff, though. Any other questions that you guys have? Just don't do double negatives on the sentence interpretation.
How much did you count off for missing?
1,000,000 points. Oh, negative mistakes can be, no, this is a really good question. Negative mistakes, if they're at the end, are 1 point. If they're at the beginning, if it's a big problem, it could be 8 to 10 points. So, you don't want to make negative mistakes. But the attempt is still 1 if you at least attempt.
Not after the first semester.
Not after the first semester.